Tonight, we uncover the moment the most expensive eye ever built looked into the deep silence of the void and saw the physical boundary where our reality simply stops. Imagine a machine built with such staggering precision that it can detect the faint thermal signature of a single bumblebee at the distance of the moon. This is the James Webb Space Telescope, humanity's ultimate machine of certainty, a 3-story tall sentinel of gold and beryllium sent 1 million miles away to provide the final word on the history of existence. We expected it to confirm the elegant, predictable equations of Albert Einstein and the standard model that has guided us for a century. But when Webb opened its eyes, it didn't see the smooth, infinite vacuum we were promised. Instead, it returned a ghost, a structured, repeating geometry that has no business existing in our cosmos. It is a fingerprint on the glass of reality, an impossible landmark suggesting that our entire universe, everything we have ever seen, measured, or loved, is nothing more than a single room in a building that is much, much larger and far more dangerous than we ever dared to imagine. To understand how reality broke, you have to understand the silence of the L2 point. 1 million miles from Earth, the James Webb Space Telescope sits in a gravitational pocket of perfect stillness, shielded from the roar of the sun by a tennis court-sized sun shield. It was here, in this absolute cold of -233 degrees Celsius, that the mission team prepared for a routine procedure that should have been entirely forgettable. They pointed the telescope at a patch of sky known as a quiet field. In the world of cosmology, boring is a technical term of great value. This specific region had been mapped for decades by every instrument we possessed, Hubble, Spitzer, and ground-based arrays, and was catalogued as unremarkable, a cosmic blank page with no galaxy clusters, no hidden mass, and no gravitational anomalies. It was supposed to be the control, the empty canvas used to calibrate the telescope's mirrors to ensure they were seeing with absolute truth. But when the first data packets from that empty field streamed back to the control center in Baltimore, the room went silent. The data was wrong, or rather, it was supposed to be wrong. Tucked inside the infrared returns was a pattern, not a smear of noise or a soft gradient of background light, but a structured, repeating signal with a geometry that had no match in any known cosmic phenomena. The analysts didn't jump to the conclusion of a different universe. They did what scientists do when reality misbehaves. They blamed the machine. They checked the alignment of the 18 hexagonal mirror segments, each coated in gold, to catch the faintest infrared whisper from the dawn of time. They tested the beryllium for microscopic warping. They ran the calibration again, and a third time. They accounted for every possible source of interference, from the faint glow of the solar system's dust to the internal heat of the telescope itself. The signal didn't move. It wasn't a ghost in the wiring, it was a ghost in the sky. The photons Webb captured had been traveling for 11 billion years, light that set out when the universe was less than 3 billion years old, long before our sun had even ignited. And somewhere along that immense crossing, something had bent them. Something had organized them. Something had marked them in a way that defied the laws of every model built since Einstein. This is the moment where the calibration ghost turns from a technical nuisance into a profound existential threat. In standard physics, when light is bent, we call it gravitational lensing. We've seen it thousands of times, light curving around the massive weight of a galaxy cluster or the invisible scaffolding of a dark matter halo. But gravity follows a specific, elegant curve, a mathematical template that Einstein's general relativity describes with total authority. The signal Webb found followed a different curve. It was too flat, it was too extended. It didn't look like light bending around a concentrated point of mass. It looked like light bending along a massive, extended surface, a wall. This discovery shatters the comfort of Einstein's cosmological constant, the idea that the energy of empty space is a stable, unchanging figure. For 25 years, dark energy has been the most embarrassing problem in physics because our predictions are off by 120 orders of magnitude, a 1 followed by 120 zeros. But if Webb has found the wall of another universe, that blunder suddenly has a terrifyingly simple explanation. The energy isn't missing from our math, It is borrowed leakage radiating from the wall of a neighbor. Dark energy isn't an internal property of our universe. It is the heat of another reality pressing against ours, bleeding through the boundary and forcing our space to accelerate outward. The implications of this are far more disturbing than a simple error in our maps. For a century, we have operated under the problem of induction, the belief that because the laws of physics work here, in our local neighborhood, they must work the same way everywhere. We assumed gravity, light, and time were universal constants, but the Webb signal suggests a paradigm shift, the idea of physics as geography. What if the laws we've spent centuries discovering are not universal truths at all, but merely the local rules of our specific bubble? Imagine you have lived your entire life inside a single room, studying the way air moves and how objects fall to the floor. You develop complex equations to describe the universal law of the room. But then for the first time you find a telescope powerful enough to look through a crack in the floorboards, and you see that outside that room, the air is missing, the gravity pulls in a different direction, and the very constants of nature are transformed. You haven't discovered a new kind of physics. You've discovered that your physics is just a local dialect. The calibration ghost is the first evidence that our complete universe is just a single room in a much larger, multi-connected building, a domain with a wall we were never meant to see. The geometry of the signal matches what theoretical physicists have feared for decades, but could never prove: a domain wall. This isn't a wall made of matter or bricks. It is a surface where space-time itself undergoes a phase transition, where one version of reality ends and another begins. It is a boundary thinner than an atom, located at the edge of our observable reach, where the constants of nature, the strength of gravity, the mass of an electron, the very speed of light, start to change. As the analysts in Baltimore stared at the ghost in the calibration field, they weren't just looking at data. They were looking at the limit of human knowledge. They were seeing a coherent, planar surface oriented perpendicular to our line of sight, a sheet of something else that has been quietly sculpting the cosmic web of our universe for billions of years. The voids in our galaxy maps are slightly larger on one side. The filaments are slightly thinner. Something outside our universe is tugging on our matter, dragging our galaxies toward a boundary we can never cross. The calibration ghost is our first true look at the wall of the room. We expected Webb to show us the beginning of our world. Instead, it has shown us the edge of it. And as we peer deeper into that signal, we are forced to confront a disturbing new reality. Our laws of physics are not eternal. Our Big Bang was not the start, and we are not alone in the void. We are simply observers in a bubble, finally beginning to understand that the wall is real and it is closing in. Tonight, we explore the forbidden door tucked inside Albert Einstein's most sacred equations, a door that leads to the physical edge of our universe. For over a century, we have rested our entire understanding of reality on a single, elegant flaw of mathematics. We believed that the laws of physics were universal, unchanging, and absolute, providing a complete map of everything that ever was or ever could be. But what if the mapmaker himself saw something in the ink that he refused to show the rest of us? What if the most successful theory in human history contains a mathematical trapdoor, a valid, calculated region of space-time where our universe simply ends and another begins? As the James Webb Space Telescope peers into the infrared silence, it isn't just finding old stars, it is finding the physical manifestation of Einstein's greatest fear. We are no longer looking at the dawn of time, we are looking at the wall of the room. To understand the crisis we now face, we must go back to the very foundation of our scientific world, to the floor of the cosmos itself. Albert Einstein did not believe in a multiverse. He spent the final decades of his life in a solitary, almost obsessive quest for a theory of everything, a single, unified set of equations that would bind gravity, light, and matter into one beautiful, solitary reality. To Einstein, the idea that reality could be fundamentally plural, or that there could be other universes operating under entirely different laws, was not just unlikely, it was philosophically repugnant. He wanted a universe that was a closed system, a singular masterpiece where every law applied everywhere, at all times, without exception. But mathematics has a habit of being more honest than its authors. Einstein's general theory of relativity, expressed through a set of 10 complex field equations, is perhaps the most successful theoretical framework ever devised. These equations describe the very fabric of space and time, telling matter how to move and telling space how to curve. They predicted black holes before we could see them, they predicted gravitational waves before we could hear them, and they predicted the bending of light before we had the tools to measure it. Yet, buried deep within the logic of those 10 equations was a feature that troubled Einstein until the day he died. They allow for solutions that describe more than one connected region of space. They contain the blueprints for a multiply-connected geometry, a mathematical reality where our universe is not the only patch of space-time that satisfies the laws of physics. Einstein left the door open in the math, even as he tried to keep it shut in his mind. He didn't want the door to exist, but the field equations insisted that under specific conditions, the geometry of space could be multiply-connected, creating a boundary between separate regions of reality. For 100 years, we treated these solutions as curiosities, mathematical ghosts that lived in textbooks but had no place in the real world. We assumed we lived on an infinite single floor. But James Webb has just walked through that door. When the telescope returned that structured, repeating signal from the quiet field, it didn't just break our models of galaxy formation, it aligned with a specific, terrifying profile in Einstein's math. To a physicist, every object in the sky has a signature, a way of bending light that reveals its true nature. We are used to point source lensing, where light curves around a heavy object like a galaxy cluster or a black hole. Those curves are steep, elegant, and drop off in a predictable pattern. But the Webb signal followed a curve that was too flat. It was too extended. The light wasn't bending around an object, it was bending along a surface. In the forbidden regions of Einstein's equations, this surface has a name, a domain wall. This is where the story shifts from technical anomaly into pure existential horror. A domain wall is not a wall made of matter or atoms. It is a surface where space-time itself undergoes a phase transition. Think of it like the boundary between ice and water, or the thin, shimmering line where a field transitions from one stable energy state to another. In the physics of the early universe, fields can settle into different ground states, different valleys of energy. If two regions of space settle into different states, the place where they meet forms a physical barrier, a wall thinner than an atom that stretches across billions of light years. The Webb signal matches the profile of such a wall with uncomfortable precision. The shear pattern detected in the data, the subtle stretching of background galaxies, maps onto a massive planar sheet oriented perpendicular to our line of sight. It is a sheet of something else that has been quietly sculpting our cosmic web for 13.8 billion years. This is the reveal that current competitor videos completely ignore. The Webb telescope hasn't just found a new phenomenon. It has found the physical limit of our universal laws. For a century, we have operated under what philosophers call the problem of induction, the arrogant belief that because gravity and light work a certain way in our local neighborhood, they must work that way everywhere, in the infinite void. We looked at a tiny sample of the cosmos and declared it the standard model for all of existence. But the domain wall suggests a devastating paradigm shift. Physics as geography. Imagine you are standing in a room with a specific temperature, a specific air pressure, and a specific gravity. You spend your whole life measuring these things and call them the universal laws of nature. But then you find a telescope powerful enough to see the wall of the room, and you realize that on the other side, the temperature is different, the pressure is different, and the very constants of reality are transformed. You haven't discovered a new kind of physics. You've discovered that your physics is just a local dialect of a much larger, more alien language. The domain wall that Webb has likely touched is a boundary of causality. It marks the end of our bubble. Einstein's equations allowed for this. They permit regions where the curvature of space-time obeys different rules, But Einstein himself hoped we would never find the edge of his floor. He wanted the room to be the entire building. Instead, Webb has shown us the plaster on the wall. This is the forbidden door in the math. The field equations are honest because they are mathematical, and math doesn't care about human comfort or the ego of a Nobel laureate. If the energy density at the boundary of two universes is non-zero, then that boundary will exert a gravitational pull. It will bend light into a specific, flat geometry, and that is exactly what is sitting in the Webb data packets. When the analysts in Baltimore first saw the profile of this lensing signal, they tried to fit it into the existing flaw of science. They looked for galaxy clusters, those massive gravitational objects that typically bend light. They found nothing. They looked for dark matter filaments, the invisible scaffolding of our universe. But filament lensing produces a characteristic, elongated smear. The Webb signal was coherent, circular, and incredibly smooth, matching the signature of an extended boundary, not a localized clump of matter. Every conventional explanation failed. The methodical procedure of elimination has left us with one surviving candidate. Something that is not part of our universe is bending our light. The reveal of the domain wall shatters the very idea of universal constants. We used to believe that the mass of an electron or the strength of gravity were absolute truths, baked into the very fabric of the cosmos. But if our universe is just one bubble sitting inside a larger, eternally inflating background, then those constants are just the initial conditions of our specific decay. We are living in a region where the rules happen to land on values that permit life. On the other side of the wall Webb has detected, those rules might be radically, lethally different. Crossing that wall wouldn't just be a trip to a new location, it would be a cascade of physical changes at the atomic level, as your constituent particles are forced to obey the constants of a neighbor. Your atoms wouldn't work there, your light wouldn't travel there. Einstein's math was a machine of certainty that accidentally provided the blueprints for its own limitation. He gave us the tools to map our room, but those same tools now tell us that the room has an exit we can never use. Webb has found the fingerprint on the glass, the structured, repeating geometry that marks the place where our reality stops. As we stare at the calibration ghost, we are forced to admit that we are not the masters of a single, infinite cosmos. We are observers in a bubble, finally touching the cold surface of the container. We came looking for the beginning of our world, but instead we have found the edge of it. And the most disturbing realization is not that the wall exists, it's that according to every measurement we have made since Webb opened its eyes, the wall is much closer than we ever dared to believe. Tonight, we examine the most embarrassing mistake in the history of science, a mathematical blunder so massive it suggests the energy of our universe is actually being borrowed from something else. For 25 years, physicists have lived with a secret they rarely discuss in public. Our best equations for the vacuum of space are wrong by a factor of 1, followed by 120 zeros. It is a discrepancy so large that it cannot be dismissed as a rounding error or a minor oversight. It represents a total collapse of our logical understanding of the cosmos. We call this mystery dark energy, an invisible force that makes up 68% of everything in existence and is currently pushing the galaxies apart at an accelerating rate. But the James Webb Space Telescope has just uncovered data that suggests this energy isn't an internal property of our universe at all. It is the heat of a neighboring reality bleeding through a wall we were never meant to see, a borrowed leakage from another universe that has been masquerading as a fundamental law of physics while it slowly prepares to dismantle the foundations of our reality. To understand the magnitude of the crisis we now face, you have to confront what physicists call the most embarrassing problem in the history of science. For decades, our standard model of the universe, the lambda-CDM model, has relied on a single number called the cosmological constant. This number, represented by the Greek letter lambda, was originally introduced by Albert Einstein as a mathematical fix to keep the universe stable, a decision he later famously called his greatest blunder. Ironically, we were forced to revive his mistake in the late 1990s when we discovered that the universe wasn't just expanding, but accelerating. To explain this, we assumed that empty space isn't actually empty. It has a built-in energy density and intrinsic weight to nothingness itself. However, when our most brilliant minds used quantum field theory to predict exactly how much energy should be in that empty vacuum, they arrived at a figure that was catastrophically wrong. The theoretical prediction was 120 orders of magnitude larger than the value we actually observe in the sky. To put that in perspective, imagine trying to weigh a single grain of sand and being off by more than the mass of every star in the observable universe. This is not a simple gap in our knowledge. It is a chasm that suggests the very flaw of our physics is built on a hallucination. For a generation, we have hidden this 120 order of magnitude blunder behind the term dark energy, hoping that a more precise measurement would eventually save us. That hope was just extinguished by the James Webb Space Telescope. Instead of confirming that dark energy is a stable, unchanging constant, Webb's observations of early galaxies and the latest surveys from instruments like the Dark Energy Spectroscopic Instrument suggest that dark energy is dynamic, it is evolving, and it may even be weakening. This is the apocalyptic storytelling that mainstream science is currently grappling with. If dark energy changes, the fate of the universe is no longer a predictable expansion into a cold void. It becomes an unstable, living process whose rules are shifting under our feet. This brings us to the profound twist that original documentaries often miss, a theory emerging from the deepest vaults of speculative cosmology. What if the energy isn't missing from our math because our math is wrong, but because the energy isn't ours? The law vault offers a more cinematic and perhaps more accurate explanation. Dark energy is borrowed leakage radiating from the wall of a neighboring universe. Think of our universe not as an infinite, self-contained vacuum, but as a bubble or a room inside a much larger building. In this room, we have studied the laws of nature and concluded that there is a mysterious, faint heat coming from the walls. We have tried to write equations to explain why the floor of our room is naturally warm, but our math keeps telling us the floor should be trillions of times hotter than it actually is. The crisis of the 120 order of magnitude blunder is the realization that the heat isn't coming from the floor at all. It is radiating from a massive fire in the room next door. The domain wall Webb has likely detected, that surface thinner than an atom located 11 billion light-years away, is not just a boundary, it is a physical radiator. In the framework of eternal inflation, our universe is just one pocket of space among an unimaginable number of others, each separated by a wall where the constants of nature undergo a phase transition. These walls carry their own immense energy, and that energy does not stay neatly contained on the surface. It leaks into our interior space in the same way that heat radiates from a warm surface into a cold room. From our perspective, stuck deep inside the room, this leakage looks like a diffuse, space-filling energy contribution with no local source. It looks constant across large scales because the wall is so immense, and it drives the acceleration of our space because it is an external pressure pushing against our boundaries. This provides a terrifyingly simple explanation for why Einstein's cosmological constant was off by 120 orders of magnitude. The energy we are measuring isn't a property of our empty space, it is the tiny fraction of energy that manages to bleed through the wall of a neighbor. The reason the observed value is so suspiciously small is simply because the boundary is far away and the leakage rate is low. This realization shatters the idea that our universe is a closed system. For a century, we have operated under the belief that the laws of physics are universal. But Webb has transformed cosmology from a study of universal laws into a study of cosmic geography. If the expansion of our universe is being dictated by the proximity of a neighbor, then our fate is no longer determined by our own internal physics. We are being tugged and pushed by structures that exist outside our reality. The Hubble tension, the fact that different parts of our sky seem to be expanding at different rates, is no longer a measurement error in this new paradigm. It is evidence that we are closer to the wall in some directions than in others. The fringe theory that was once muttered in the hallways of physics conferences is now moving to the center of the room. Our region of space-time is being influenced by something adjacent to it, something with its own energy and its own expansion history that is bleeding through at the margins. This borrowed leakage explains why the voids in our galaxy maps are slightly larger on one side and why our filaments are slightly thinner than they should be. We are witnessing a quiet billions of years long reorganization of our matter. Something outside our universe is tugging on our galaxies, dragging them toward a boundary we can never cross. As we look at the data from James Webb, the most embarrassing problem in physics takes on a new, darker meaning. We haven't just found a mistake in our math, we have found the limit of our sample size. We have been like people trying to explain the climate of the entire world by looking out a single window, only to realize that the laws we discovered were actually just the weather patterns of a single valley. Dark energy is the first hint of that outside weather. It is the signature of a different universe pressing against ours, and its presence suggests that our universal constants, the mass of an electron, the strength of gravity, are merely the initial conditions of our specific bubble. If the energy driving our expansion is indeed borrowed leakage, it implies that our universe is not an eternal masterpiece, but a transient pocket. The 120 order of magnitude blunder was the first warning sign that we were trying to apply the law of the room to the entire building. And as Webb peers deeper into the infrared silence, it is confirming that the heat from the wall is real. We are living inside the shockwave of a cosmic meeting, a reality that is being sculpted by a neighbor we will never meet, but whose energy is currently tearing our sky apart. The 120 order of magnitude blunder was never just a math problem, it was an existential clue. It was the universe's way of telling us that we were not alone in the void, and that our certainty was only ever a local illusion. Now with Webb, we are touching the surface of that container, and we are finally beginning to understand that the energy of our existence is a debt we can never repay. Tonight, we explore the possibility that the Big Bang was not the beginning of our existence, but the aftermath of a violent cosmic impact. For nearly a century, we have told ourselves a singular, comforting story of creation, the story of a tiny, infinite point that blossomed into everything we see. We called it the Big Bang, a name that suggests a solitary explosion in a void that didn't exist until the explosion made it. But as the James Webb Space Telescope peers into the infrared silence, it is uncovering evidence that our origin was far less lonely and far more chaotic. We are finding that the oldest map of the sky, the afterglow of creation itself, is not just a record of cooling gas, but a series of reverberations. It is the ringing of a struck bell, a resonance that has persisted for 13.8 billion years, suggesting that our universe did not simply appear. It was struck by something else. We are beginning to realize that we are living in the shockwave of a meeting between realities, and the marks of that collision are still visible if you know exactly where to look. To understand the shift from the Big Bang to the Big Impact, we have to look at the standard model of cosmology, the Lambda CDM framework, not as a failure, but as an incomplete history. This model has been the gold standard for decades because it predicted the most important feature of our sky, the cosmic microwave background, or the CMB. The CMB is the oldest light we can detect, a faint, universal glow that was released when the universe was just 380,000 years old. It is a map of the universe's infancy, filled with tiny temperature fluctuations that represent the seeds of every galaxy and star that would ever form. For 30 years, we believed these fluctuations were caused by random quantum noise during a period of rapid expansion called inflation. We assumed the pattern was internal, a domestic feature of our own bubble. However, there is a different mechanism that produces a nearly identical pattern of fluctuations, one that doesn't rely on random internal noise, but on an external force. Theoretical work over the last 15 years has demonstrated that when two bubble universes in an eternally inflating background approach each other, the collision zone isn't just a point of contact. The wall separating the two universes oscillates, it rings like a struck bell. These oscillations send waves of energy through the spacetime of each universe, imprinting a specific spectrum of fluctuations that is mathematically indistinguishable from the noise predicted by standard inflation. This is the Big Impact theory. The idea that the fluctuations we've been crediting to quantum chance are actually the echoes of our universe being struck by a neighbor at birth. The evidence for this collision has been hiding in plain sight for 2 decades, buried in a region of the sky that standard cosmology has politely tried to ignore. In the southern sky, in the direction of the constellation Eridanus, there is an anomaly known as the cold spot. It is a region of the CMB that is significantly colder than the average, about 70 microkelvin below the background. In the context of the oldest map of the universe, the cold spot is enormous, spanning an angular patch roughly 5 degrees wide. For 20 years, this bruise on the cosmos has caused significant institutional discomfort because the standard Big Bang model simply has no clean way to explain it. The first attempt to explain away the cold spot was the supervoid hypothesis. Scientists argued that an immense region of below-average matter density along the line of sight was cooling the light as it passed through. But when the math was finally done with precision, it was found that the largest void in the model could only account for a fraction of the temperature drop. The cold spot remained larger and deeper than any internal structure could justify. The second defense was to call it statistical noise, a rare but possible fluke of chance. It was a way of saying the anomaly wasn't interesting enough to investigate, a closing of the doors on a mystery that didn't fit the singular narrative of our origin. But the Big Impact theory offered a third candidate that sat in the literature for years, largely ignored by the observational community: a bubble collision imprint. The mathematics of bubble collisions predicts a very specific kind of signature in the CMB, a roughly circular region of altered temperature with a specific profile across its boundary. The cold spot in Eridanus matches this prediction with haunting accuracy. It looks exactly like the mark left behind when 2 expanding boundaries meet in the void, yet, without a second piece of evidence, the bruise remained a controversial curiosity. That second piece of evidence has just arrived from the James Webb Space Telescope. This is where the story shifts from speculative math into a unified set of observational consequences. Webb was pointed at a calibration field, a patch of sky meant to be empty, and it found a structured, repeating lensing signal. This signal wasn't caused by a galaxy or a black hole, it was caused by an extended planar surface that physicists call a domain wall. When researchers overlaid Webb's new signal onto the older maps of the sky, they made a discovery that has redefined the boundaries of our universe. Webb's lensing anomaly aligns perfectly with the cold spot in the CMB. These 2 anomalies, separated by billions of light years and discovered using entirely different instruments, are pointing toward the same coordinate in the void. The probability of 3 independent anomalies, the cold spot, Webb's lensing signal, and an asymmetry in the cosmic web, aligning by chance, is low enough that we are forced to take the boundary hypothesis seriously. We are not looking at random errors, we are looking at a pattern. Something touched our universe 13.8 billion years ago and it left more than one mark. The cold spot is the thermal echo of the impact, and Webb's signal is the physical boundary of the universe that hit us, still pressing against our space today. This realization transforms the Big Bang from a moment of creation into a moment of transition. In this paradigm, our entire cosmic history, every supernova, every nebula, and every moment of stellar evolution was set in motion by the impact of 2 expanding boundaries in the void. We are the children of a collision between universes. Our physics, which we once thought of as universal and eternal, is merely the aftermath of that impact, a local ringing that has settled into the patterns we see today. This shift in perspective is what we call physics as geography. It means that the laws of nature we've discovered aren't absolute truths of the cosmos, but the specific local conditions of our particular bubble. Imagine being born inside a room that is still vibrating from a heavy blow. You spend your life studying the vibrations and call them the universal law of sound. You develop complex equations to describe how the air moves, never realizing that the sound isn't an internal property of the room, but the resonance of the room being struck. Webb is the first instrument to look at the wall of that room and see the ghost of the strike. The implications for our understanding of time are just as disturbing. If the Big Bang was an impact, then before the Big Bang isn't a logical impossibility. It's just the time before our bubble nucleated and collided. It suggests that there is a larger background environment, a parent structure, that existed before we did. Some theorists argue that our universe might even be the interior of a black hole born in that parent universe, and the rotation of that parent is what gave our galaxies their preferred axis of spin. Every galaxy Webb sees spinning in the same direction is a memory of that ancestral rotation. This Big Impact narrative solves the most persistent headache in cosmology, the 120 order of magnitude dark energy blunder. For 25 years, we couldn't figure out why empty space had so little energy. But if our universe is a bubble pressed against another, then dark energy is just the heat of that neighbor leaking through the boundary. The energy isn't ours, it's borrowed. The acceleration of our expansion isn't an internal force, it's the pressure of another reality pushing against our wall. As we stare at the alignment between Webb's lensing signal and the Eridanus cold spot, we are forced to admit that our standard model has been a story told from a sample size of 1. We assumed the universe was a closed, infinite system. Instead, we have found that it is a region, a subset of something older and stranger than anything we had imagined. The ringing bell of the Big Bang is the sound of our bubble finally being placed in context. We are observers in a room that is still vibrating from its birth, and for the first time we have touched the cold surface of the container. The silence beyond the wall that Webb has detected is not an empty silence, it is a causal boundary. Information cannot cross it, yet its gravity and energy sculpt our very existence. We know the neighbor universe is there because we are still feeling the resonance of the impact. We are living in the afterglow of a meeting between worlds, and as Webb peers deeper into that calibration ghost, it is confirming that the Big Bang was never the beginning, it was only the start of our story. As we move deeper into the infrared silence, the James Webb Space Telescope begins to uncover something that feels less like astronomy and more like archaeology, or perhaps something far more unsettling. We are finding that the young universe is not the empty, primitive place we were promised, but a graveyard of monsters that should not exist. In the deepest, darkest patches of the sky, Webb has detected objects that have sent a shiver through the cosmological community, the little red dots. These are not the sprawling, majestic spirals of our modern era, but tiny, compact crimson points suspended in an impossible darkness. To the analysts in Baltimore, these dots initially looked like noise or dust, but as the data sharpened, a terrifying paradox emerged. These objects are a few hundred light-years across at most, mere marbles compared to the stadium-sized scale of the Milky Way, yet they glow with a fierce, concentrated intensity that rivals an entire galaxy. They are too small to be galaxies, yet far too bright to be stars. They appear as ghosts from before time, signatures of a reality that operated under hidden rules, and their very existence suggests that our universe was haunted from the moment of its birth. The discovery of the little red dots has introduced a specific kind of cosmic horror into the study of our origins. In the standard story of the Big Bang, the early universe was a slow, quiet builder. It was supposed to be a place of raw, chaotic gas where the first stars flickered on like lonely candles in a vast, cold cathedral. Galaxies were expected to grow in stages, gathering matter slowly over billions of years, but these dots represent a complete collapse of that timeline. They appear as early as 600 million years after the Big Bang, reaching a peak population around 800 million years, only to vanish almost entirely by the 1.5 billion year mark. They are a transient phase, a chapter of the cosmos that appeared, reigned, and then died before the universe had even reached its teenage years. This creates a rare opportunity for storytelling that moves beyond dry mathematics. Imagine arriving at a maternity ward only to find that half the newborns are already standing, walking and speaking in deep, ancient voices. That is the technical equivalent of what Webb found. These little red dots are too massive, too organized, and too energetic for their age. They are ghosts from before the Big Bang, relics that seem to have bypassed the slow staircase of stellar evolution to arrive at the top floor before the elevator was even installed. This isn't just a technical error, it is an existential realization that the maternity ward of the universe was actually a factory for something far more predatory. To understand what these objects are, we have to look at the theory that is currently circulating in the deepest vaults of speculative physics, the black hole star. The little red dots possess a spectrum that is a disturbing hybrid, part star, part monster. They emit the warm, infrared glow of a gas cloud, yet they exhibit high-velocity gas being whipped around at speeds of up to 4,000 kilometers per second. In the local universe, such speeds are only found around the event horizons of supermassive black holes, but these dots are missing the standard signature of a black hole, the fierce, high-energy X-rays. This has led to the proposal of a black hole star, an entity that sounds like a contradiction in terms. Imagine a star the size of a small galaxy with a growing supermassive black hole as its heart. In this configuration, the black hole is not a separate object but a parasite living inside a massive, dense cloud of gas. The black hole feeds on the interior of the cloud, releasing enormous amounts of gravitational energy that causes the entire gas shell to glow. From the outside, it looks like a star, a little red dot. But its heart is a void. The gas cloud acts like a thick blanket, absorbing the X-rays and muffling the monster's scream, which is why our X-ray telescopes see nothing but silence. It is a fire wrapped in a blanket, a light that is powered by the very thing that will eventually consume it. This black hole star theory introduces a chilling aesthetic to our early history. These objects were the first light bringers, but they were fueled by destruction. They were the maternity ward where supermassive black holes were built inside out. And the question that keeps physicists up at night is where the seeds for these monsters came from. According to every law of physics we understand, black holes grow slowly. They are limited by the Eddington limit, the point where the radiation from infalling matter pushes back so hard that the black hole cannot eat any faster. To reach the masses Webb is seeing in just a few 100 million years, these black holes would have needed to start large. This brings us to the most radical implication of the little red dots. The idea that they were seeded by primordial black holes. These are black holes that were not born from dying stars in our universe, but were forged in the first second after the Big Bang, or perhaps they were survivors from a previous cosmic cycle. If our universe is part of a conformal cyclic cosmology, or a bounce universe, then the Big Bang was not a beginning, but a transition. In this paradigm, supermassive black holes from a previous aeon, or a parent universe, could have survived the collapse and persisted through the bounce. These primordial seeds would have been sitting in the void long before the first star ever ignited, acting as ghosts from before time. When the gas of our new universe began to cool, it would have been instantly drawn into these waiting traps, igniting the black hole stars that Webb now detects as little red dots. We are finding that nearly every galaxy in the cosmos, including our own, may be built around a primordial seed that is older than the universe itself. We are not living in a new world, we are living in a structure that was preceded by the remnants of a previous reality. The little red dots are signatures of another cosmos bleeding through, and their sudden disappearance from the record is just as haunting as their arrival. By 1.5 billion years after the Big Bang, the population thins and then vanishes. The black hole star phase was a brief, violent chapter where the monsters were hidden. Once the surrounding gas clouds were either consumed or blown away by radiation, the monsters were revealed as the naked, supermassive black holes we see today at the centers of galaxies. The dots didn't die, they graduated. They became the silent, predatory hearts of the universe we now inhabit. As we stare at these crimson points in the Webb deep fields, the cosmic horror becomes personal. We once thought of black holes as latecomers to the cosmic story, the inevitable end of a star's life. But Webb has shown us that they may have been the first cause. They were the architects of the first structures, the seeds around which our reality was woven. We are looking at a universe that was not born in a state of grace, but in a state of hunger. The little red dots are the first evidence that our universal laws are just a mask for a deeper, older process, a different universe that provided the seeds for our own. Every time Webb identifies another dot, it is confirming that we are living in a graveyard of previous realities. We are finally seeing the ghosts that have been quietly sculpting the cosmic web for 13.8 billion years. The most advanced telescope ever built has not found clarity. It has found a labyrinth of unanswered questions. We came looking for our beginning, only to find that our beginning was a collision, and our history is being written by monsters that existed before time itself began. The little red dots are the fingerprints on the glass, the evidence that the wall of our room is real, and the things that live outside it have been with us since the very first second. As we drift further into the infrared silence of the early universe, we find that the ghosts inhabiting the cosmic dawn are not just individual monsters, but entire cities of stars that have no right to exist. For decades, the James Webb Space Telescope was promised to us as the ultimate time machine, an instrument that would allow us to watch the very first ripples of matter slowly, painstakingly coalesce into the primitive seeds of galaxies. We expected to find chaos, small, irregular, wispy clumps of gas and newborn stars, the fragile nursery of a cosmos that was still learning how to build itself. But when the first deep-field images from Webb reached the screens at the control center in Baltimore, that comfortable story of a slow, predictable build collapsed in a single afternoon. In the deepest, most ancient corners of space, where the universe was supposed to be in its gangly, unformed teenage years, Webb found a series of twins, galaxies that are just as massive, just as organized, and just as mature as our own modern Milky Way. To a cosmologist, finding these objects is not just a discovery, it is a profound violation of the laws of time. It is exactly like opening a family photo album, turning to the page of a newborn baby's first day of life, and finding a picture where the infant is already wearing a three-piece suit, holding a leather briefcase, and asking for the car keys. This is the impossible galaxy crisis, a fracture in our understanding of reality so deep that it suggests these galactic cities didn't grow fast, they may have simply remained. The shockwaves of this discovery have sent a shiver through the institutional halls of science because our current models of the universe, specifically the Lambda CDM framework, operate on a strict, linear budget of time. According to this recipe for reality, galaxies are supposed to grow the way a snowball rolls down a hill, gathering matter slowly over billions of years, building their majestic spiral arms through a long history of mergers and cooling gas. Our own Milky Way is the gold standard for this process. It took the better part of 13 billion years to reach its current mass of hundreds of billions of suns. Yet Webb is showing us 6 specific galaxies, and now hundreds more candidates, that reached this exact level of complexity in just 500 to 700 million years. To grasp how absurd this timeline is, you have to look at the maternity ward of the cosmos through the eyes of the astronomers who first saw the data. These systems are too old, too organized, and too heavy for the age of the universe they inhabit. In the few 100 million years after the Big Bang, the universe was still hot, still cooling, and still trying to figure out how to ignite the very first generation of stars. There simply hasn't been enough time for gravity to do the mechanical work of pulling that much matter together. When researchers like Mike Boylan-Colchin of the University of Texas at Austin looked at the numbers, they realized we had entered uncharted territory. For these galaxies to exist so early, they would have needed to convert every single grain of available gas into stars with nearly 100% efficiency. Imagine a cosmic bakery that is asked to produce 1,000 loaves of bread. In our local, modern universe, that bakery is inefficient. It spills flour, it wastes water, and for every loaf it produces, it leaves behind a massive cloud of unused ingredients. We observe a star formation efficiency rate of maybe 5 or 10%. But the galaxies Webb has found are like a bakery that turns every single speck of flour and every drop of water into perfect, finished bread with zero waste, and does it 10 times faster than the laws of thermal physics should allow. It is a physical impossibility under our current universal laws, and it has forced the scientific community into a state of cosmic civil war. Some try to rescue the model by claiming we've miscounted the stars or that dust is playing tricks on our eyes, but with every new image Webb returns, those excuses grow thinner. This leads us to the most disturbing and cinematic implication provided by the deepest vaults of speculative cosmology. If these galaxies could not have grown this fast in our universe, then perhaps they didn't start in our universe. We are forced to consider the bounce universe model, a theory that replaces the singular Big Bang with a repeating cycle of cosmic death and rebirth. In this framework, the Big Bang was not a beginning, but a transition, a cosmological bounce where a previous universe contracted to a point of extreme density and then rebounded. If this is true, then these impossible Milky Way twins are not newborns at all. They are survivors. These are structures that may have existed in an aeon before ours, massive galactic civilizations that weathered the collapse of their own reality and persisted through the white-hot forge of the bounce. They appear to us as ghosts from before the Big Bang, relics that were preceded into our cosmic dawn. This would explain why they are already wearing the suit and briefcase of maturity when we first see them. They didn't spend the first 500 million years of our time growing. They spent 13 billion years of the previous universe's time evolving. When our Big Bang occurred, these massive structures were already there, acting as gravitational anchors around which the new matter of our universe began to settle. This realization transforms the James Webb Telescope from a tool of discovery into a tool of archaeology. We aren't just looking at the first galaxies, we are looking at the ruins of a previous reality that have been repurposed into the foundation of our own. This is the different universe theory in its most tangible form. It suggests that our standard model is not a complete history of existence, but merely a single chapter in a much longer, repeating book. The impossible mass of these galaxies is only impossible if you assume the clock started at zero. But if the clock has been running forever through endless cycles of bounces and collapses, then these galaxies are exactly where they should be. The psychological weight of this discovery is immense. It suggests that we are living in a graveyard of previous realities. The very atoms in your body, the heavy elements like carbon and oxygen that were forged in the hearts of stars, might have an ancestry that stretches back through multiple Big Bangs. We are finding that nearly every major structure in the cosmos, from the supermassive black holes sitting in the little red dots to these massive Milky Way twins, may be built around a primordial seed that is older than time itself. As the analysts in Baltimore continue to prune the data, trying to find a more conventional explanation, the impossible galaxies remain standing. They are the fingerprints on the glass that Einstein never wanted to see, evidence that his singular, beautiful universe is actually an unstable, living process that inherits its traits from a parent we can never fully know. We came looking for clarity, expecting to see these simple, humble beginnings of our world. Instead, we found that the maternity ward was already full of ancient, predatory structures. The Milky Way twins are a warning that our laws of physics are not universal truths, but local geography influenced by the survivors of a cosmic impact. Every time Webb identifies another massive galaxy in the deep infrared, it is confirming that our universe was haunted from the moment of its birth. We are finally seeing the ghosts that have been quietly sculpting the cosmic web for 13.8 billion years, and their presence tells us that the wall of our room is not just a boundary of space, but a boundary of time. We are observers in a bubble that is still vibrating from the strike of a neighbor, and these impossible galaxies are the debris from that collision, artifacts of another cosmos bleeding through into ours. The impossible Milky Way twins are the definitive proof that the Big Bang was never the beginning. It was only the moment we started paying attention to a story that had already been written. And as we look at these ancient cities of stars, we realize that the most expensive eye ever built hasn't just found the edge of our reality, it has found the door to the one that came before. But as shocking as these massive structures are, they are only half of the mystery. Because while these galaxies shouldn't be so large, they also shouldn't be moving the way they are. In the next chapter, we look at a discovery that breaks the most fundamental rule of the void, the rule that the universe has no direction. We are about to uncover the handedness of the void, a signal that the entire cosmos is spinning inside the heart of something even larger. Tonight, we uncover the discovery that the entire cosmos is spinning in a single direction, as if the void itself has a memory of the monster that gave it birth. Imagine flipping a coin 263 times. In a fair, random world, you would expect it to land on heads about half the time and tails the other half. It is the most basic law of probability. But when the James Webb Space Telescope looked at the rotation of galaxies in the deepest reaches of the void, the coin didn't land on its side. It landed on its face, over and over, with a terrifying non-random bias. 2 times out of every 3, the galaxies were spinning in the same direction, a statistical impossibility that suggests our universe is not a balanced, infinite expanse, but a structure with a built-in tilt. This isn't just a measurement error, it is a fingerprint of an ancestral spin, a signal that our entire reality is rotating inside the heart of something much larger. We are discovering that the vacuum has a handedness, a cosmic memory of a parent that existed before the Big Bang, and the implications of this discovery are about to rewrite everything we thought we knew about the orientation of existence. To understand the magnitude of what Webb has just broken, we have to look at the JWST survey, the James Webb Advanced Deep Extragalactic Survey. This is one of the telescope's most ambitious projects, a deep field observation that stares into the infrared silence for hundreds of hours to capture the light of the very first star cities. Because Webb's golden mirror is so large and its detectors are so precise, it returns images that are sharper than anything we have ever possessed, allowing us to see the delicate winding arms of spiral galaxies as they appeared over 13 billion years ago. In those images, galaxies appear as glowing pinwheels suspended in the dark. Some spin clockwise and some spin counterclockwise. In a truly random universe, the count should be a perfect 50-50 split. There is no reason for a galaxy 12 billion light-years away on one side of the sky to care which way its twin is spinning on the other side. But when a computer scientist named Lior Shamir analyzed the JWST data, the split wasn't even. Out of 263 spiral galaxies clear enough to analyze, roughly 175 were rotating clockwise from our point of view, while only 88 were rotating counterclockwise. That is 2/3 of the universe leaning in one direction. Shamir noted that the asymmetry is so obvious that you don't even need complex algorithms to see it. You can simply scroll through the images and watch the lean of the cosmos by eye. The odds of this happening by pure chance in a random universe are roughly 1 in 3.5 million. In the world of statistics, that isn't a coincidence, it is a property of nature. It is what physicists call a preferred axis. This discovery has detonated one of the oldest and most sacred rules in all of cosmology, isotropy. For a century, our entire understanding of the Big Bang and general relativity has rested on the assumption that the universe is isotropic, meaning it looks the same in every direction. Whether you look north, south, east, or west, the density of matter, the expansion of space, and the motion of galaxies should be uniform. Isotropy is the flaw of the standard model, the rule that allows us to write equations for the whole universe based on just the small patch we can see. If the universe has a preferred direction, that flaw collapses. It means some directions in the sky are special, and that the universe has a built-in orientation, a handedness or memory that was present from the very first second. This is the cosmic civil war in its most mathematical form. For years, institutional science tried to ignore hints of this preferred axis. We saw it in the axis of evil, an unusual alignment of hot and cold spots in the cosmic microwave background that suggested the oldest light in the sky was tilted. We saw it in dark flow, the observation that large clusters of galaxies seemed to be drifting toward a single point in the void, as if they were being pulled by a drain. But those signals were faint and easy to dismiss as measurement errors. Webb's spinning galaxies cannot be dismissed. They are physical objects, clearly oriented, providing a clean, undeniable signal that the universe has a direction. The search for the cause of this handedness of the void leads us back to the forbidden regions of Albert Einstein's equations. While Einstein wanted a universe that was a static, solitary masterpiece, his math was once again more honest than he was. In the 1940s, the mathematician Kurt Gödel used Einstein's own field equations to prove that a rotating universe was a mathematically valid solution. In a Gödel universe, the entire cosmos turns slowly around a global axis. He found this so disturbing that he almost used it to prove the equations were incomplete, because in a rotating universe, light and time behave in ways that defy human intuition, even allowing for paths that could return to their own past. For decades, the rotating universe was treated as a mathematical curiosity, a ghost that lived in textbooks but had no place in reality. But Webb has just brought that ghost to life. If the universe was born spinning, then every galaxy that formed within it would inherit a small statistical bias toward that rotation direction. Like a drop of ink falling into a whirlpool, the matter of our cosmos was stamped with the handedness of its birth. And if the universe is spinning, we are forced to ask the most dangerous question in physics. Spinning relative to what? In ordinary physics, rotation requires an external reference. You can't say something is spinning if there is no outside to measure the spin against. If our universe is everything there is, then a global rotation should be impossible. But if our universe is rotating, it implies that it is not everything. It implies a parent structure. This is where the story shifts from astronomy into the dizzying realm of black hole cosmology. The theory, championed by physicists like Nikodem Poplawski, suggests that our entire observable universe exists inside the interior of a supermassive black hole embedded in a larger parent universe. This is not science fiction. It is a valid interpretation of the Schwarzschild geometry that defines the region around a black hole. When matter falls into a black hole in the parent universe, it doesn't just disappear into a point of infinite density. Instead, according to a modified version of general relativity called Einstein-Cartan theory, the matter experiences torsion, a powerful physical twisting of space-time itself. This torsion acts like a spring. It stops the collapse and triggers a bounce, a rebound that creates a new region of space expanding in its own direction of time. From the inside of that new region, the bounce looks exactly like a Big Bang. The expansion looks like inflation. But the most important feature is that the baby universe inherits the spin of the parent black hole through that torsion. The rotation of the mother is stamped onto the daughter. This provides the terrifyingly simple explanation for Webb's 2/3 spin anomaly. Our galaxies spin in a preferred direction because they were born inside a rotating monster. The handedness of the void is the ancestral memory of the black hole that gave us life. Every clockwise spinning spiral galaxy captured by James Webb is a piece of evidence that our universe is not a solitary event, but a node in an endless tree of cosmic rebirth. This realization shatters the idea that the laws of physics are universal truths. Instead, we must confront the paradigm of physics as geography. If our spin is inherited from a parent, then our constants, our expansion rate, and our very standard model are merely the local conditions of our specific bubble. We are living in a region of space-time that was sculpted by the initial conditions of a collision or a collapse that happened before our time began. The institutional discomfort with this idea is immense. To admit that the universe has a preferred axis is to admit that we have inferred universal laws from a sample of one. It means our universal constants, like the mass of an electron or the strength of gravity are just the weather patterns of our specific valley in a much larger landscape. Some researchers have tried to rescue the old model by suggesting that our own Milky Way's motion is creating an illusion of asymmetry, a Doppler effect that makes one rotation direction appear more common than the other. If this is true, it is still a crisis. It would mean every distance measurement we have made in the last 50 years has a hidden, systematic error. Whether the asymmetry is a cosmic rotation or an observational bias, the result is the same. The universe is not what we thought it was. We have found a preferred axis, a signal that space has a direction and a memory. Webb has shown us that the flaw of our physics, isotropy, is cracked. We are observers in a bubble that is still vibrating from its birth, carrying the spin of a parent we can never see. As we stare at the JD's images, at the hundreds of tiny, glowing pinwheels spinning 13 billion years in the past, we are no longer just looking at galaxies. We are looking at the fingerprints of a different universe that provided the seeds for our own. We are looking at the handedness of a reality that began inside a black hole, a reality that is far older, larger, and more connected than Einstein ever dared to imagine. The void is not empty, and it is not random. It has a direction, it has a history, and it is telling us that our room is not the whole building. The spin is real, and the wall is closing in. Tonight, we uncover the physical limit of human existence, the place where the laws of nature are stripped away and our reality simply stops. For decades, we have stared at the night sky and seen an invitation to infinity, a vast and open dark that surely continued forever in every direction. We believed that if we just built a powerful enough eye, we could see to the very beginning of time and across the very edge of space. But when the James Webb Space Telescope opened its golden mirrors at the L2 point, it didn't find an endless corridor. It found a stop sign. It found a structured, repeating geometry sitting 11 billion light-years away. A ghost in the infrared dark that suggests our entire universe is merely a single room in a much larger, more alien building. This isn't a mystery about what is in our universe. It is a discovery of where our universe ends. We are no longer looking at the stars, we are looking at the wall of the container, and as we are about to learn, the territory on the other side of that wall is so fundamentally different that if you were to step across it, your very atoms would cease to function. To understand the anatomy of the edge of everything, we must first look at the incredible distance that separates us from the silence. The photons that James Webb captured in that unremarkable quiet field have been traveling for 11 billion years. They set out on their journey when the universe was less than 3 billion years old, long before the Earth had cooled into rock and long before our sun had even ignited. For eons, this light crossed the expanding void, only to be bent and organized by something sitting at the very rim of our observable cosmos. When the analysts in Baltimore processed this data, they realized the distortion didn't match the signature of a galaxy or a black hole. It matched the profile of a surface. This is the physical nature of the domain wall, not a wall made of matter, bricks, or atoms, but a surface where space-time itself undergoes a profound phase transition. In the language of theoretical physics, a domain wall is the boundary between two different regions of the vacuum. Imagine a ball that can settle into the bottom of any one of several valleys in a vast energy landscape. In the first fraction of a second after the Big Bang, the inflaton field, the driver of our universe's exponential expansion, had to decay to a lower energy state. In our region of space, the field settled into one particular valley, giving rise to the laws of physics we know, the strength of gravity, the mass of an electron, and the speed of light. But in an adjacent region, the field settled into a different valley. Where these two incompatible regions of reality press against each other, they form a domain wall, a sheet of pure energy and tension that stretches across billions of light years. The anatomy of this wall is almost impossible for the human mind to grasp. It is a surface thinner than an atom, possibly as thin as the Planck length, the smallest meaningful scale in all of physics, roughly 10 to the power of -35 meters. For all practical purposes, the barrier has no thickness. You would cross it in an instant. Yet, within that infinitesimal sliver of space, the very foundations of reality are rewritten. It is a phase transition boundary similar to the line between ice and liquid water, but instead of changing the state of matter, it changes the state of the laws of nature themselves. On our side of the wall, gravity pulls with a certain strength, and light travels at a constant speed. On the other side, those numbers, the universal constants we have spent centuries cataloguing, simply do not apply. This leads us to the paradigm of physics as geography. We have spent the history of our species assuming that the laws we discovered in our local neighborhood were universal truths baked into the fabric of the entire cosmos. But the Webb signal tells us that our physics is actually just a local dialect. We are like people who have lived their entire lives inside a single room, studying how objects fall to the floor and calling it the universal law of the room, only to find a telescope powerful enough to look through a crack in the floorboards and see that outside, the gravity pulls in a different direction. The domain wall is the place where our local laws end. 11 billion light-years away, at the edge of the bubble, Webb has detected the constants of nature, gravity, light, and electromagnetism begin to shift. The danger of this boundary is not merely that the view is different, it is that the physics is incompatible with our existence. If you were to somehow travel to this wall and cross it, you would not find a new landscape to explore. Instead, you would trigger a cascade of physical changes at the atomic level. Your atoms are stable configurations precisely because our local constants of nature are fine-tuned to allow them to exist. If the strong nuclear force that binds atomic nuclei together were even slightly weaker on the other side of the wall, your atoms would immediately fall apart. If the electromagnetic constant shifted, the chemical bonds holding your DNA together would vanish. To cross the wall is to enter a region where your constituent particles are forced to obey the rules of a neighbor, rules that do not permit the structure of a human being. You wouldn't just die, you would be fundamentally reorganized into a different state of matter. This is why the domain wall is a one-way information barrier. Light from the neighboring universe cannot cross that surface and remain interpretable as light in ours. The physics of the crossing would alter the photons beyond all recognition, stripping them of the information they carry. We can know the boundary exists because of the gravitational lens it casts upon our background galaxies, but we can never see through it. The neighboring universe has its own past light cone, its own history, and its own causality that does not overlap with ours. Whatever has happened on the other side of that wall has had zero influence on our history, and we have had zero influence on theirs. We are two realities adjacent in space, but causally isolated in time. The existence of this wall shatters the cosmological constant problem that has embarrassed physicists for 25 years. We have struggled to understand why the energy of empty space is so bizarrely small, 120 orders of magnitude, smaller than our math predicts. But if Webb has found the wall at the edge of everything, we finally have an answer. The energy isn't ours. It is borrowed leakage radiating from the wall of a neighbor. The acceleration of our expansion, what we call dark energy, is merely the heat of another reality pressing against our boundary, forcing our space to stretch outward. The energy we measure is small only because the wall is 11 billion light-years away, and the leakage rate is low. As the James Webb Telescope stares into that quiet field, it is capturing the first direct evidence of our containment. We are observers in a bubble, finally touching the cold surface of the container. This realization turns the telescope from a tool of discovery into a tool of archaeology and geography. We are finding that our complete universe is just a subset of a much larger background structure. The calibration ghost isn't a mistake, it is the fingerprint on the glass of our reality, the mark left by another universe that hit us 13.8 billion years ago and is still pressing against us today. The wall Webb has detected is not just a mathematical curiosity, it is the existential end of our sample size. We have spent centuries looking out a single window and declaring that we understood the climate of the entire world, only to realize that the laws we discovered were actually just the weather patterns of our specific valley. Beyond that wall, the weather is different. The universal constants we thought were eternal are merely the initial conditions of our local decay. We are living in a region where the rules happen to land on values that permit stars, planets, and observers to exist. The horror of the domain wall is the realization that we are prisoners of our own physics. We can see the exit, but it is an exit we can never use. Webb has shown us the plaster on the wall, and in doing so, it has revealed that our room is much smaller than we ever dared to imagine. The silence beyond that wall is not an empty silence. It is the boundary of somewhere else, a reality that has been sitting just beyond our reach for longer than our sun has existed. We came looking for our beginning, but Webb has found our edge. And as the data continues to stream in from that distant boundary, we are starting to understand that the wall is not just real, it is closing in. Tonight, we uncover the possibility that our universe is not an infinite expanse of matter and energy, but a contained environment, a single room in a vast, multi-storied complex where the rules of existence are being managed by a force we can barely comprehend. Imagine for a moment that the calibration ghost James Webb detected, the structured, repeating signal at the edge of the void, is not a wall of matter, but a limit of logic. We have spent centuries assuming that the universal constants of our reality were absolute truths baked into the very foundation of the cosmos. But as we peer into the deepest infrared silence, a terrifying new framework is emerging from the most uncomfortable corners of philosophy and physics. We are beginning to realize that the boundary Webb has touched might be a rendering limit, a place where the physics engine of our reality transitions between regions of different resolution. Whether our container is made of bubble walls or lines of code, the realization is the same. Our complete universe is just a subset, a single room in a much larger building that we were never meant to leave. We are no longer just observers of the stars. We are subjects in a containment paradox, and the wall is the only thing telling us the truth about our place in the hierarchy of existence. To understand the magnitude of this paradox, we must first confront a philosophical argument that has made physicists deeply uncomfortable for over 2 decades. It is known as the simulation argument, formalized by philosopher Nick Bostrom in 2003. The logic is deceptively simple. If it is possible to simulate a universe with enough fidelity that the entities inside cannot tell the difference, and if civilizations tend to advance to a point where such simulations become feasible, then simulated universes will eventually vastly outnumber real ones. If that is true, then the probability that we are the original base reality observers becomes vanishingly small. For years, this was treated as a fascinating thought experiment, a late-night debate for the fringes of science. But when James Webb found a physical boundary at the edge of the observable universe that looks like a structured planar surface, the simulation argument moved from philosophy into the realm of observational consequences. The first reading of the Webb data through this lens is perhaps the most disturbing. In any simulation, computational resources are finite. Even a civilization with unimaginable technology could not render an infinite universe with perfect physical fidelity at every scale in every location. A computationally efficient simulation would only render in full detail the regions actively being observed by its subjects, dropping the rest of the cosmos to a lower resolution or skipping them altogether. If this is the nature of our reality, the boundaries of the rendered region might leave artifacts in the data, anomalies and signatures that do not fit the internal physics of the system. The domain wall that Webb detected 11 billion light-years away could be interpreted as exactly such a rendering artifact. It is a place where the simulation's physics engine transitions between domains, a boundary effect in the code itself that manifests as a geometrically clean, repeating signal. This interpretation is not just a flight of fancy, it is a response to the structured and repeating nature of the signal. Webb returned from a calibration field that was supposed to be empty. Scientists expected a blank page, but they found a geometry that has no match in any known natural phenomena. In a natural, infinite universe, light should bend around concentrations of mass in a predictable, steep curve. But the Webb signal is too flat and too extended, looking less like light curving around an object and more like light bending along a surface. If you were looking for the seams in a constructed reality, this is exactly where they would appear, at the limits of our vision, where the rules of geometry begin to stutter. This leads us to a profound realization that connects two of the most controversial theories in modern science. If the universe is a bubble inside a larger background, as predicted by the math of eternal inflation, and if it is a simulation inside a larger computer, as predicted by the math of Bostrom, the two frameworks become structurally identical. The question of whether the container is physical or mathematical may not be the most important question for those of us stuck inside. Both theories describe an observer inside a constructed system that contains them, isolated from a vaster environment they can never fully access. Whether we are trapped by a physical wall of transitioning field states or a limit in a high-fidelity rendering engine, the existential truth is the same. Our observable universe is not everything. It is a region, a subset, a portion of something larger. This containment paradox shatters the century-long dream of finding a theory of everything that applies to the entire cosmos. For decades, we believed that if we just looked deep enough, we would find a single set of equations that bound the universe together. But Webb has shown us the plaster on the wall. It has revealed that our universal laws are not universal at all. They are local geography. We have spent centuries studying the way objects fall in our room and calling it the universal law of gravity, only to realize that we have inferred universal truths from a sample of one. If we are in a container, then the constants of nature, the speed of light, the mass of an electron, the strength of electromagnetism are just the initial conditions of our specific domain. They are the settings chosen for our room in the building. The scale of this building is provided by string theory, which has long been haunted by its own reputation for being too complex to test. String theory does not produce one solution for the universe. It produces an astronomically large number of them, roughly 10 to the power of 500. To put that number in perspective, it makes the estimated number of atoms in the entire observable universe look like a rounding error. Each of those 10 to the power of 500 solutions describes a possible universe with a different set of physical constants and different rules for reality. For decades, this landscape of possibilities was seen as a failure of the theory. But in the post-Webb era, the landscape is being reframed as a map of what actually exists. Eternal inflation samples this landscape, nucleating new bubble universes indefinitely, each corresponding to a different point in the building. If Webb has found the nearest boundary to our bubble, it is a measurement of the distance to the edge of everything we have ever known. It tells us that we are part of a multi-connected geometry, a mathematical reality where our universe is not the only patch of space-time that satisfies the equations of physics. This is the forbidden door that Albert Einstein left open in his field equations, even as he tried to keep it shut in his mind. Einstein wanted a universe that was a closed system, a singular masterpiece. But his math was more honest than his philosophy. It allowed for solutions where regions of space are separated by domain walls, surfaces where the fabric of reality itself undergoes a phase transition. The horror of the containment paradox is the realization that we are prisoners of our own physics. We can see the exit, but it is an exit we can never use. As we discussed in earlier chapters, crossing the domain wall wouldn't just change your location, it would trigger a cascade of physical changes at the atomic level because your atoms would not work under the rules of the room next door. This creates a one-way information barrier. Light from the neighboring universe cannot cross that surface and remain interpretable as light in ours. The physics of the crossing would strip the photons of the information they carry. We are two realities adjacent in space, but causally isolated in time. This realization brings a strange kind of grief to our understanding of the cosmos. The sense of a cosmic home, a universe that was ours from edge to edge, is dissolving into something vaster and more impersonal. We are observers in a bubble looking at the wall, finally beginning to understand that the wall is real. But there is also an expansion of what it means to know anything at all. The fact that we have detected the boundary using a machine made of gold and beryllium a machine designed by a species that only recently learned how to fly, is evidence that reality is richer and more deeply structured than any model we had built to contain it. As we stare at the calibration ghost, the distinction between a physical boundary and a rendering limit begins to fade. If the math of eternal inflation and simulation theory is structurally identical, then the nature of the code becomes irrelevant. What matters is the containment. We have found the fingerprint on the glass of our reality, the structured, repeating geometry that marks the place where our version of existence stops. We came looking for the beginning of our world, but Webb has found our edge. And as the data continues to stream back from the L2 point, one question remains that the telescope can never answer. If our universe is just one room in a building, and if the 120 order of magnitude blunder proves that we are borrowing our energy from a neighbor, what happens to the building when the rooms begin to change? We are living inside the shockwave of a meeting between realities, a big impact aftermath that is still ringing like a struck bell. We are finally touching the cold surface of the container, and we are starting to understand that the wall is not just real, it is closing in. The calibration ghost is our first true look at the wall of the room. We expected Webb to show us the dawn of time. Instead, it has shown us the physical manifestation of Einstein's greatest fear. We are not the masters of a single, infinite cosmos. We are observers in a subset, finally beginning to grasp that the building is much, much larger than we ever dared to imagine. And as we peer into the silence beyond that wall, we are left with the most disturbing realization of all. We are not alone in the void, but we are permanently, perfectly isolated. We have traveled across the debris of a cosmic impact through the maternity ward of black hole stars and past the impossible cities of the early universe, only to arrive at the most difficult truth of all. The James Webb Space Telescope has not shattered Albert Einstein, but it has done something far more humbling. It has turned his universal laws into a local approximation. For a century, we treated Einstein's general relativity as the absolute final word on the nature of space and time, a set of equations that dictated the behavior of every atom from the center of our sun to the farthest reaches of the void. We believed that we were mapping the entire building of existence, only to realize that we have spent our history meticulously documenting the furniture of a single room. Webb's detection of the structured repeating signal 11 billion light-years away, the calibration ghost, is the moment the plaster on the wall finally became visible. Einstein's math still holds and his flaw is still beneath us, but we must now accept that it is a bounded flaw, a subset of a much larger and more terrifying architecture. The resolution to this crisis is not the destruction of our science, but its refinement. Just as Isaac Newton's laws were not wrong when Einstein arrived, but were revealed to be the truth of a specific regime, slow speeds and weak gravity, Einstein's own theories are now being exposed as the truth of our specific bubble. We are witnessing the first major contraction in the history of human knowledge. Every time Webb identifies another massive galaxy that should not exist, or another spiral galaxy spinning in the direction of its ancestral parent, it is confirming that our standard model is an incomplete history. We have found the edge of our sample size. In the world of science, this is known as the problem of induction, the arrogant belief that because gravity and light work a certain way in our local neighborhood, they must work that way everywhere in the infinite dark. This realization forces us to abandon the quest for universal laws and embrace the new paradigm of cosmic geography. We have spent centuries looking out a single window and declaring that we understood the climate of the entire world, only to realize that the laws we discovered were actually just the weather patterns of our specific valley. The constants of nature, the speed of light, the mass of an electron, the strength of the force that binds your DNA together, are not absolute truths baked into the fabric of the cosmos. They are merely the initial conditions of our specific decay, the settings chosen for our particular room in the building. On the other side of the domain wall that Webb has likely touched, the weather is different, the gravity pulls in a different direction, and the very constants of reality are transformed. The existential weight of this discovery is immense. We used to believe that the universe was our home from edge to edge, a singular masterpiece where we were the masters of everything we could see. But as the golden eye of Webb looks deeper into the infrared silence, the sense of a cosmic home is dissolving into something vaster and more impersonal. We are observers in a bubble looking at the wall, finally beginning to understand that the wall is real. We are like children who have found the boundary of their backyard, only to realize that the rest of the world is not only off limits, but operates under rules that would tear our very atoms apart. Crossing that domain wall wouldn't just change your location, it would trigger a cascade of physical changes at the atomic level because your atoms would not work under the rules of the room next door. You wouldn't just die, you would be fundamentally reorganized into a different state of matter. This creates a one-way information barrier that marks the true end of our reach. Light from the neighboring universe cannot cross that surface and remain interpretable as light in ours. The physics of the crossing would strip the photons of the information they carry. We can know the boundary exists because of the gravitational lens it casts upon our light, but we can never see through it. This is the silent frontier. It is the discovery of a limit, and in physics, limits are often more important than the things they contain. The speed of light led us to relativity. The Planck scale pointed toward quantum gravity, and the domain wall now leads us to the realization of our own containment. We have reached the point where the unknown stops floating above us like fog and begins attaching itself to coordinates. We know approximately how far the boundary sits, we know something about the energy density of the wall itself, and we can feel the resonance of the neighbor that hit us 13.8 billion years ago. But beyond that, there is only a causal opacity. The most embarrassing problem in physics, the 120 order of magnitude dark energy blunder, now has a terrifyingly simple explanation. The energy that is tearing our sky apart isn't missing from our math, it is borrowed leakage from the wall of a neighbor. Dark energy isn't an internal property of our universe, it is the heat of another reality pressing against ours, forcing our space to accelerate outward. We are living inside the shockwave of a meeting between worlds, and the ringing of a struck bell that we call the Big Bang is the only soundtrack our bubble will ever know. As we look at the data from James Webb, the cosmic civil war between mainstream science and revolutionary speculation begins to find a quiet, uneasy peace. The anomalies that once looked like errors are now being accepted as landmarks. The galaxies that were too massive and the black holes that were too fast are the fossils of a reality that existed before our time began. We are finding that our universe was haunted from the moment of its birth. And these ghosts are the only clues we have to the nature of the building we inhabit. This realization brings a strange kind of grief. The sense that we were part of a single, infinite cosmos is being replaced by the reality of isolation. We are not the masters of a singular masterpiece. We are subjects in a containment paradox. Whether we are trapped by a physical wall of transitioning field states or a limit in a high-fidelity rendering engine, the existential truth is the same. Our observable universe is not everything. It is a region, a subset, a portion of something larger that we can never fully access. And yet there is an expansion of what it means to know anything at all. The fact that a species that only recently learned how to fly has built a machine capable of touching the surface of its own container is evidence of a profound victory. Webb has shown us that reality is richer, stranger, and more deeply structured than any model we had built to contain it. We have not found clarity, but we have found a labyrinth, one filled not only with galaxies and black holes, but with the fingerprints of a different universe that provided the seeds for our own. As the analysts in Baltimore continue to prune the data, they are no longer just astronomers. They are archaeologists of the absolute. They are mapping the ruins of previous realities and the boundaries of our current one. The calibration ghost isn't a mistake in the mirror segments. It is the physical manifestation of Einstein's greatest fear, the mathematical trapdoor that he never wanted us to open. We have walked through that door and we can never go back to the comfort of the universal constants. The James Webb Space Telescope, humanity's ultimate machine of certainty, has accidentally delivered us to the edge of everything. It sits 1,000,000 miles away at the L2 point, shielding its golden eye from the roar of our sun to look into the silence of the neighbor. It sees the clockwise spinning galaxies, the little red dots hiding monsters, and the massive twins of our own Milky Way. All signals that we are part of a multi-connected geometry where our universe is not the only patch of space-time that satisfies the laws of physics. But as Webb stares deeper into that structured, repeating geometry, at 11 billion light-years, it eventually reaches a point where there is nothing more to see. Beyond the domain wall, information cannot cross. There are no signals to receive, no stars to map, and no weather to document. There is only the boundary of somewhere else, a reality that has been sitting just beyond our reach for longer than our own star has existed. We know it is there because we can see the mark it left on our structure, our sky, and our light. This is our final view of the cosmos, a golden eye staring into the absolute dark of a causal boundary. We have mapped our room, we have found the wall, and we have even felt the heat from the room next door. But we are left standing at an exit we can never use, looking back at a universe that was always a local outcome of a process that was larger, older, and stranger than we ever imagined. The James Webb Space Telescope has given us the most profound discovery a telescope has ever found. Not an object, not an event, but the physical boundary of our reality. And on the other side of that boundary, separated from us by a surface thinner than an atom and farther than the mind can hold, the answer to the final question sits in perfect, permanent silence. We know the wall is there,